We all fight daily against the fake arguments of plastic not being as circular as paper, for example. If we manage to create a circular stream for plastic, we must assure that the material can be reused with as little extra effort as possible and that something useful can be made from it. If that is maintained, then David Katz's idea that plastic garbage becomes a valuable thing will create its own economy. Today, what can we really make out of recycled plastic, other than park benches or flower pots? But this demand is limited. Therefore, the full cycle is a highly desired must-have. So let's come to our next presenter, Professor Edward Kosior from NextLooPP. NextLooPP is working on reusing the plastic for its original purpose. That means a yogurt cup becomes a yogurt cup again. In the next presentation, Professor Ed Kosior will inform us about the status of today's technology. NextLooPP, closing the loop for PP recycling, a technology update. Professor Kosior's expertise in the plastic recycling sector spans 46 years, split between 23 years as an academic and 23 years working in plastic packaging recycling. He has been instrumental in designing numerous modern recycling plants and has achieved a number of patent recycling breakthroughs. He also provides support to organizations such as the Earth Champion Foundation, Plastic Oceans, PEW Foundation, Trust on the project Stopping Ocean Plastics, and is the founder of NextLooPP, the multi-client project aimed at closing the loop on food-grade PP.
Hello, my name is Edward Kozia. I'm the Managing Director of Nextek and NextLooPP, and my talk today is on closing the loop on food-grade polypropylene packaging. Nextek is a company that is focused on the recycling of post-consumer packaging. We've been doing this for over 17 years, and we develop unique solutions for barriers to the recycling of packaging. And we also design recycling factories to allow materials to be made to be used back into the circular economy. This talk is about the recycling of polypropylene, which has been one of the major polymers used throughout the plastics industry. It's being made at the rate of about 60 million tonnes per annum. It's approximately 20% of the global production of plastics. And in Europe, we use 10 million tonnes of polypropylene for a wide range of applications due to its very high stiffness to weight ratio, its toughness, its insolubility, its moldability, the capacity to make fibres, sheet, injection molded items, and many other materials. So highly versatile, widely used, yet right now it's not widely recycled. And of course, that means that the lack of recycled material will inhibit the use of recycled polypropylene back into packaging materials. And in Europe, we have a charge being applied to packaging without 30% recycled content, and that's 800 euros per tonne. In Britain, by next April in 2022, it will be £200 per tonne. And these taxes and charges are there to encourage the use of recycled content back into new materials. And in Europe, the 4 million tonnes that's used in packaging would generate a demand of 1.2 million tonnes per year. And at the moment, there is no food-grade recycled polypropylene, and this is why we have developed the NextLooPP project to address this gap. And as you know, brand owners globally have been making commitments to reach recycled content targets. Typically, these targets are 25% recycled content by 2025. And in some cases, the recycled content is going to go to 50 or even to 100%. And of course, the retailers that are putting packaging into the hands of consumers are also feeling the pressure and the need to adopt recycled content in packaging. Supermarkets like Marks and Spencer's, Co-op have already made very clear and strong commitments to use recycled content in their packaging. Tesco also recognised the view that food-grade PP materials would be welcome to address their initiatives. Morrisons and Iceland also see recycled polypropylene as a key step forward in the inclusion of material back into packaging. And the key here is the contact with food. Recycling of PP happens right now, but back to lower value or downcycled applications. And food packaging is much more demanding, and this has been the gap. We started the NextLooP project, and we now have 30 companies that are involved in the project, and they cover the full supply chain, from the recycling of material to the conversion of resin into packaging formats, to the supplies of technology involved in the recycling process, and also industry associations and government organisations like RAP UK and groups like OPRL, who are involved in the definition of the recycling logos. We have label companies and ink companies who are involved in the supply of part of the technology. So, and also universities to conduct further research. So the NextLooP initiative is based on two technology platforms. The first one is a sorting technology, which is called Polyprism, and the other one is a decontamination technology called Pristine. And these two platforms have been developed by 8 years of intense research in order to make these systems plug and play ready. And they are now ready for use. And we have designed both platforms to be usable with the current infrastructure that's available to the recycling sector in United Kingdom and Europe. Polyprism is the sorting technology, which is based on the use of markers that fluoresce under ultraviolet light. This is a very simple step. We have a library of markers that can be used to tag a bottle or a package so that it can be identified uniquely. This allows us to select and sort the material, and so we can segregate food from non-food, or we can use other categories such as bio-based plastics or black plastics and many other things. But our focus for polypropylene will be separating food from non-food. And we can achieve 95% purity in one step, greater than 99% purity in two steps at very high speeds, 3 meters per second at loading rates of 2 tons per hour per meter width of belt. So Polyprism is the separation technology. We have a short video to show you this at work. In this video, you'll see 2 types of bottles that have fluorescent marker sleeves on them. They look like conventional bottles under normal daylight, so the markers are invisible. But here we've mixed them with many other plastics. Under ultraviolet light, the marked bottles fluoresce. The cameras that are used in the sorting system can see the fluorescence, and they are ejected. And as you can see in this video, the separation is very complete. As we've said, greater than 95% selectivity in each step, which means that we can gain very high separation of one type of material to another. And we have shown that this technology can be applied to existing recycling installations, such as the one we've got shown here, where we're able to fit the ultraviolet light source and the software to the sorting system in under an hour, and then successfully sort fluorescent marker-based materials on the system. So the marker technology is plug and play ready to go, and we don't have to install new equipment, but we have to simply upgrade those units to the new system. On the decontamination technology, we've got our NextLooPP pristine system, and this slide shows the decontamination efficiency on the basis of what's called a challenge test. In this challenge test, we apply a number of surrogate chemicals to polypropylene, and we look to see whether we can extract those materials by the recycling process. So we've actually used, in this case, 6 chemicals, and they are meant to represent the whole spectrum of chemicals that might be able to be found in the consumer's home, or if they happen to be used in a package. So we have low molecular weight, high molecular weight, polar and non-polar molecules of various types. And in this particular table, you can see that the removal rates, the decontamination rate here, is of the order of 100% going to 95% depending on the molecular weight. Those very high decontamination rates, coupled with the high initial concentrations, can be used to predict whether we can actually decontaminate this to food grade conditions. And indeed, we have done the testing looking at migration of these surrogate chemicals into food simulants, and we've shown that the materials are not extracted at all, or they're below the level of detection. And that means that we have confidence that this material meets food grade requirements as specified by EFSA. And the experimental results have been inspected by and validated by Steptoe and Johnson, who specialise in food grade regulations. And this gives us the confidence that this process will be able to create a new stream of food grade recycled polypropylene, provided the correct pre-treatment and sorting is carried out to provide the input materials. The NextLooPP project will deliver a series of milestones along the supply chain. So besides developing the recycling infrastructure for polypropylene food grade materials, it will also establish the certification that will give brand owners, consumers and recyclers the confidence that the process is fit for purpose and the materials are indeed food grade. And it will enhance the current recycling programs of recyclers and produce greater returns for them. It will also develop specific grades of materials for film, sheet, thermoforming, blow moulding and injection moulding. And we will also develop a series of design guidelines for food grade recycling so that brand owners, retailers and converters can produce materials that keep on enhancing the quality of recycled materials as they go through multiple loops. The NextLooPP program is designed to benefit the businesses that are making and recycling packaging in United Kingdom and in Europe. The innovation will help companies meet their recycling targets, and it will help keep packaging costs low by avoiding the charges that would otherwise be applied if they had no recycled content. And very importantly, the recycling of polypropylene will reduce the carbon footprint of the packaging that's being produced. For each tonne recycled, at least 1 tonne of CO2 will be saved compared to using virgin resin. And this is compared against landfill as a destination. And the savings are approximately 2 tonnes of CO2 equivalent if the material is destined to go to waste to energy. NextLooPP Recycled PP is meant to be a direct replacement for virgin PP. and this will help companies produce materials and make products that will be able to be used as a drop-in replacement, so making the whole process relatively simple and straightforward. Just to highlight some of the areas of progress in the NextLooP project, the first plant will be built by Viridor in United Kingdom, and the capacity will be of the order of 7,000 to 10,000 tonnes per annum, and it's expected to be delivering material by the end of 2022, next year. The grades of material that will be made will be a natural white combination, which we can often call ivory, and also a grey made from the multicoloured materials. And these will be available as 100% recycled content materials. And in addition, we will develop hybrid grades that will be mixed with virgin polypropylene for special technical performance applications such as thin wall injection moulding, or perhaps some sheet extrusion, or areas where we need high rigidity. The grades, as I've mentioned, are suited for injection moulding and extrusion because these are the main conversion techniques. And the recommended addition rate would be of the order of between 25 and 50%, even though 100% is possible. And the reason why we're recommending the lower addition rates are purely so that more products can actually be tested and produced with recycled content rather than focusing on a smaller number of products. There is a new development that the NextLooP program will undertake as well, and it's to produce inert grade polypropylene, which is a new grade of material which will be applicable to many cosmetic applications, and it will provide a very economic material which will be very well suited to non-migratory conditions needed for cosmetics. The NextLooP program will provide a lot of opportunities for the businesses that are participating, and they will be able to have supplies of food-grade recycled polypropylene for their internal testing. Now, that will mean processing, the evaluation of mechanical properties and organoleptic properties and migration performance. All of these steps are needed to make sure that every end market can be met by food-grade recycled polypropylene. And this is an important part of the whole program so that everyone can actually have confidence from beginning to end that recycled polypropylene is viable for those particular areas of market. Companies can also come to NextLooP to become a licensee so they can actually manufacture these materials. We already have one confirmed and one more in process of negotiation, and we are getting inquiries about other areas. So we welcome this activity. Also in the NextLooP project, we know that the companies participating will be the first to bring their products to the market with recycled content, making them product leaders in this area. There is ongoing demand for this material. Here are the materials that we're working on. You can see on the left the bales of post-consumer rigid packaging that are being sorted, in this particular case, audited for their characteristics. And on the right-hand side, we can see the packaging made from food-grade recycled material. And of course, the various colours that will be made will be matched with the appropriate end market applications. So the NextLooP program is one that is ready to deliver food-grade recycled PP to the packaging industry. And even though this is a pioneering activity, we're confident that it will be the start of closing the loop on recycled polypropylene, making this material part of the circular economy. And our direction is that all of these packages would be 100% recyclable and 100% recycled. So thank you for listening to my talk, and we welcome inquiries about NextLoop, and we welcome the opportunity to work with you in closing the loop on food-grade recycled polypropylene. Thank you very much.
Well, thank you, Professor Kosior. That was a very interesting presentation. I can't wait to get PCR, food-grade PP. We have some time for questions. I see in the chat that no questions have occurred, but from the ETT board, we do have a question. Where do you expect the sorting and recycling industry to move in the coming years, and how will they create economy with more material streams going forward?
Is, can they be recycled back into a food grade material? And this requires a new type of sorting, a sorting with fluorescent markers. And this will be the next step that will have to happen. Brand owners that want to take their material back through the loop will have to have one way of differentiating the material. And so we propose the use of fluorescent markers to do that. However, we will have other grades that will be suitable for non-food applications, and polypropylene is used in many. So, for example, we have a grade which we're calling Inert grade, which has very low migration limits, which is eminently suitable for the cosmetics industry. Now, that industry specifies food grade, yet what they really want is a grade that doesn't contaminate or migrate into the non-food cosmetics materials. So the polypropylene sector really does have a big opportunity to catch up in the recycling content of its products. And we hope the NextLooP program will create high quality materials, both food grade and high quality non-food grade materials.
All right, thank you very much. I think we have time for one more question. And that is, what role do you expect chemical recycling to play in the future for PP?
Okay. So chemical recycling is, I think, a big opportunity for the industry to create a loop on its materials. However, we've got a long way to go before...
It's okay, you're on.
It's all right. Works well.
Sorry, we had a bit of a gap. Can you hear me now?
Yep.
Yep, okay. So chemical recycling is a technology that is essentially in its very beginnings in the petrochemical sector. The principle of chemical recycling is you use the input materials like a polypropylene package back into hydrocarbons, and then you put it through the whole refining chain. Now, the problem with chemical recycling is you don't get a quantitative product. So you might do this with PET, but with polypropylene, you get random chain scission. And while you can make a pyrolysis oil, you don't make a product that's directly broken down into monomers. And so it doesn't make a very simple process. So chemical recycling is hopefully something that will happen in a big way, but we know it's not happening now, and it will probably take quite a while before chemical recycling becomes a big factor in the recovery of plastics packaging. And the one factor that I think that holds chemical recycling back is the higher carbon footprint that it has. So it misses out on the opportunity to have a reduced carbon footprint, which mechanical recycling will have. So this is probably one of the inhibitions, although it's a very necessary process because there are many materials on the market today that are not easily recyclable. And so ideally, we would use mechanical recycling for conventionally easy to recycle materials, and would put complex materials like multi-layers, multi-materials into the chemical recycling area where we break it down to carbonaceous materials. But we still have a long way to go for this to become a major stream of material that is actually going back into new materials again. But everyone we know is working on it, and we hope to see this grow fairly quickly to make sure we don't have too much material that's left lying around and not being used as a useful form of carbon back into new useful materials.
Thank you once again, Mr. Kosior, for this presentation and answering the questions. We still have some questions in the chat. We would prefer to answer them in writing and display them in our webpage. You will receive the link for that also. All right, then back to Herb.
Thank you.